Peter originally has been trained as an electrical engineer working in digital signal processing and computer science, but his application area has been in linguistics and trying to understand how the human brain processes and acquires languages. And in that regard, Peter, if you could help me learn Spanish better, I would really appreciate it.
Well, speaking in English is a very hard job for me.
No,
So-
let me, one more word is, and recently he has taken on leadership of an initiative called Fair Digital Objects, which is the subject of his presentation today. FAIR grew out of some working group activities in the RDA and other areas, and we all know the FAIR acronym today: findable, accessible, interoperable, and reusable. And Fair Digital Objects aim to translate those capacities into the exchange of digital information in a seamless way. And with that, Peter, I will let you explain further why Fair Digital Objects are so important.
Thank you very much, Bob. And thank you for inviting me to this meeting. I realize that's always dangerous to come to a meeting with people who you don't know, since they speak a certain language. And I already had a good introduction by you folks about what you are doing here, which gives a much better insight. And I hope still that I can give you some ideas about fair digital objects and why they are useful. Of course, as we just heard, fair data is important. And I will explain a bit maybe what fair could mean. I think the previous speaker asked that, what is fair, how to make fair, what does it really mean? So, so let me try to do my best to tell you a bit about fair digital objects. And as you will see, I start from a different angle than you did. You speak about a coherent information system, basically, which you design and so forth. I speak more about an infrastructure aspect, right? Bringing data together from different parts. So that's a bit of different angle. And what I will do is short bio, tell you a bit who am I, but very short, since Bob already mentioned that. Talk a bit about metadata, persistent IDs, and the FAIR principles. But as I just heard, I can make that short. And then speak a bit about the state of data in general, not about your system. That looks excellent, but data in general. And then come to what we call globally integrated data space and fair digital objects. So here we are. So I come from an institute that was busy studying the human brain when we are talking, listening, and learning language and so forth, and was responsible for technology and methodology. We start, and as you can see, we used all kinds of nice equipment, which you can imagine, of course, as we all do. And our science was from the beginning on data-driven. And of course, we applied statistical algorithms, all what we could get and create ourselves. And these algorithms are data hungry. So very early, we understood that our own institute was good, but not good enough to get enough data for certain analysis. And that's something you probably know. So we needed to start to think about starting infrastructure. So getting people from different institutes together to see how we can integrate also the data, how we can access the data. That was in the 80s. And I will tell you a bit how that was at that time. Since it was very difficult for us to get data, we started being responsible for data infrastructure or research infrastructure, so international and European ones. I mentioned here Dobis, Clarion, and UDAT. So large infrastructures, all with the intentions to increase interoperability, to increase the FAIR principles, although at that time we didn't know anything about the FAIR, the 4 letters. And as Bob said, since nothing fits together, that was my experience from these big infrastructure projects, which, by the way, you can also still look at the web. Since nothing fits together at different levels, we started with the Research Data Alliance with a few of us, and then later started the Fair Digital Object Forum, where I will explain a bit about why we did so. Okay, so let me be very brief here, since I already have the understanding that you understand what I want to say here. So if someone goes to a library offense has something, I would like to have a book, access to a book and some shelf somewhere, which was there at 5 years ago, the librarian would probably have big question mark and say, what do you want? I can't help you. So I need an ISBN number. And you all know that ISBN number, it's kind of eternal. And some metadata, author or title or whatsoever. And of course, this the rationale behind this, a place in a shelf is not a persistent identifier. It's very simple. Just to mention this again. Well, of course, you all know these cards, these small electronic cards, which are now electronic, and there you have a stable part and a part which is changing from time to time when there's some reorganization in the library or so. And the stable part is, of course, the ISBN number and some metadata. Nothing new for us. So if we transform this to the digital world, it's what we see is, and what we know is, and you mentioned this already in your talk, is the principles basically stay the same. We have, as you can see, can I use the pointer? Yes. Of course, we have a PID, a real PID, not a shelf identifier, a PID. You see here a DOI and a handle, and a DOI is also a handle with a certain prefix, nothing different. So there is a PID and what doesn't persistent means, it's a social contract. Of course, we all know this. So we believed in the digital DOI since the big librarians are behind that, and the handle is part of the same game. So we believe in these since there are big communities behind this. So they stay kind of eternal. Never use that word so in the true word, but they stay for a long time. That's what we believe. And of course, there's some metadata. So we created a simple schema. And then I could already start with FAIR principles. You need a structure, make your structure available, and of course vocabulary. And you showed how you're doing this in a very nice way as well. So you need a persistent identifier, and a URL is not as a location in a store. Don't forget that. Well, I can skip this. I wanted to show that, of course, modern metadata is much more complicated than the simple one which we used in this repository which I had, but you already gave an excellent example about a complex metadata scheme. And basically all the communities which I know about were busy with creating complex schemas. And again, the point is having the schemas out there and the definitions of the vocabularies, of course. I will come back to this in a moment. So metadata and persistent identifiers are well-established concepts. Librarians have shown their importance for many activities and many years. And the digital domain is basically similar, but it's much more diverse and complex. But these principles, as I said, seem to be eternal. So let's use them. Now, just a short look at what is basic difference between the world of books and the world of data. Well, the books, 150 million books, I looked it up in the web, still is a lot, but it's still overseeable. And the good part is books are human readable, right? So we can read them and you can find them in libraries. The stuff with data is completely different. So alone in our small data repository in our Max Planck Institute, we had in 2012, when I stopped officially, we had about more than 1 million digital objects stored in the library in our storage systems and had to manage them. And of course, we used, as you also, complex schemas, since our people wanted to search for certain brain diseases and certain ages and so of the subjects and so forth. And just to give you another number, our climate simulation people, those people who create this report for the UN, who are internationally organized, they create about 100,000 objects in a night with their simulation runs, right? So these are completely different numbers, and we all know them. Sorry, we all know them. We can't count the number of digital objects which are created everywhere. We can't count them anymore. And quantities require new mechanisms, of course. And of course, we want to access all research artifacts, and that's, of course, a difference with respect to the publication world, which we are familiar to. So what is the state now? So I made the turn from the world of books to the world of data, which is not so new for you probably. But what is now the state of data? These are citations from a few years ago, but they are still valid. If you look at several surveys, and you look at data projects in industry or science, it doesn't really matter. 80% of the time and the money, of course, in data project is wasted with data munging. So before you really can press the analysis button, do my analysis, you have lost 80% of the money. And it may be now a bit less since people are doing the efforts to become better in data management, but still the number is high. Patrick Hydon, another well-known person, made a survey and said in 20 years, 80% of our digital will be lost. Well, you create now with your community here data, which is not allowed to be lost in a few years. You create a lot of knowledge in these structures which you are creating. It's knowledge which needs to be preserved. So this is a danger. When we then go to infrastructure, I can cite Wittenberg, who is an internet pioneer. We are risking the digital dark age. I'm not sure whether we mean the same when we talk about what the way we should take, but his claim is that we are risking the digital dark age looking to these numbers. We're not there to have a good management system in overall. People work in silos, nothing bad with this, and silos disappear or are not accessible anymore or not understandable anymore. We're still there. And we lack, and Bob Kahn, another internet pioneer, we lack a persistent, stable, and global data management solution. Again, why is that so? Since we all think still in silos, so we're all working on our own part of the solutions for our domain, for our purposes, and what we see is there's a lot of fragility. Structures which we are creating are ephemeral. They disappear after a few years. And that's a really danger. And it's almost the same kind of utterance than from Windsurf. And Tim Berners-Lee, a web pioneer, even said we need a radical change, a new architecture. Again, I'm not sure whether we talk about the same way of thinking, but that's what he said. Now, let's see. I come to the FAIR principles. So I already had a chat, and you mentioned them again and again, the FAIR principles. I think the first two are kind of simple. Metadata is required. When we wrote the FAIR principles, we said rich metadata. No one knows exactly what that means. Since metadata is there, and that's one answer to your questions. The whole FAIR principles are about machine actionability. You called it a bit in your diagram a bit different, not readability, actionability. So that if a machine finds a term, that the machine knows what to do. You can do it in different ways. You can use a simple way of saying, okay, here's a term, and there's an action. You define an action for that term. And that I come to this, which is a simple way to make things actionable. So findable, clear, we all know that we need to have rich metadata and put it out to service providers. Accessible, we need a good access protocol and so forth. Interoperability, what does it mean? When we wrote this, we discussed about this term interoperable. There's nothing per se interoperable. If you say something, energy, whatever, I will not understand this or so. So there's nothing per se interoperable. We always have to map between semantic systems. The main point here is you have to, as I already mentioned, and you do a good job, obviously, you have to register your schemas, put them out there, and you have to register and define all your concepts which you are using, so that some smart people can do this mapping and then create interoperability if you want. Well, just to mention again, but obviously this is known. FAIR does not mean open data. Of course, we all like as much open data as possible, but it's not open data. It does not mean open data. So what I want to say here is that, of course, metadata and PIDs are Essential for fair, to be fair, of course, PIDs that are stable. The state of data is bad, as we heard, and it's still so. And we urgently need measures to improve the state of data and need to urgently reduce costs to make data projects feasible for many. I don't know, by the way, this was a discussion coming up recently, how generative AI will change this game, right? It is a game changer. I'm not sure at this moment to how far this will go, but these large language models or foundational models will have an effect on what we are doing. So I mentioned the term feasibility. Now, so if we want to be 100% fair, as I said, it means machine actionability. Now we have thousands of repositories out there, a huge amount of repositories out there in small departments and big universities and so forth. It's a lot, and they were established or created in the last 2 decades or so, mainly. Mostly they are underfunded. Having them all on a fair level will cost a huge amount of money and will cost a lot of time. It's almost impossible. So a fast integration as a first step is nevertheless possible for less money. How to do it? So my colleague George Schrawn, another internet pioneer, made this nice diagram and said, look, fair for machines, so really machine actionable with all what we are doing, will cost a lot of time to make this transition in all the repositories. Fair for humans, so that means having good metadata, but not something which machines immediately understand, but human can see it, is already a huge step for many repositories. Still, will require a lot of time. Here's something which allows integration, fair digital objects. Now, let me see that I explain this to you a bit. In fact, and that's why George is so fond of this solution, since he was one of the internet pioneers. What we basically suggest is repeating the internet success stories. You may all remember, the older ones of you may all remember, IBM, DEC had all their internet solution, their network solutions, and they were also packet switching solutions. So why TCP/IP? Well, the big point was there were many islands out there, and TCP/IP was then the agreed. Not everyone was happy, but was the agreed, thing brought in all together. So the integrating all the different islands and not trying to change everything at once. So IBM, I think it cost them 5 or 6 years to smoothly transfer their own internet into the TCP/IP true stack. So this is something which again and again happens if you look to large data spaces, infrastructures. And so if you compare, if you look to how the railroad system developed, how electrification developed, internet, you all start with islands, small islands. They're partly getting bigger, and at a certain moment, people are so far that they agree on a kind of standard to bring them all together. And the question is then, is that true for a data space? So can we create a global integrated data space? That was our question. So it's a bit different question, or slight different question as you address. How can we create a basic interoperability layer to bring all these different islands together? Of course, everything needs to be based on fairness, and we need to take care that trust in all this integration is part of the game. I will not talk about this today. So this is now the point for fair digital objects. It's a very simple unit, basically. I like this yellow diagram. I think, come on. This guy there, we were part in the meeting when we launched the first time of the term fair digital object, Simon. And we used in a bit different colors, but basically what we want to express is there are persistent atomic units of fair information identified by a PID, by a persistent identifier. And these atomic units bundle all the information which is necessary to process a certain digital object. That's basically the whole core, right? So you have a digital object that could be a semantic relation, or it could be a piece of data, a brain image, or what have you, right? And this piece of data has then different types of metadata. It could be the Dublin core stuff. It could be rights information. So we are working together with industry now, and of course, industry is very much interested to have detailed rights information, and to tell others what they are allowed to do with the data and so forth. So you have different types of metadata, and the FDOs are persistent units that bundle all these different types of information so that a user can then use the information or not. And that the user gets the metadata information and all the kind of things which are necessary, like schemas and so forth, right? You can bundle them in together. So I hope it's clear. This fair digital object does not solve the issue of semantic mapping. That's not our business. Semantic mapping could be an object, fair digital object, right? But it's solving the problem that all the information which is necessary to do fair processing of a brain image or what have you is possible. And so it's no miracle behind this. The point is simply, if everyone would do it, then it's like TCP/IP, you have a global semantic. That's the whole issue. So there's nothing, mystery. There's no mystery behind this. And the good point is, you have so many repositories out there, and the repositories don't have to be changed right away. What you need is adapter. So we've created one adapter recently for a repository, and it cost us a good programmer a week to do this adaptation and to tell the outside world, I'm a fair digital object provider, right? So that's the point. The fair digital objects don't operate on rights. It's like TCP/IP, it's like HTTP. The protocol does not work on rights, which is important, since rights, if you talk about rights, you talk about roles of people, you talk about certain legislations. They're all different if you cross the country border. So leave the finger away from this. What you need to do with the FDOs is, of course, bundle the rights information, if there's rights information, and pass it through to the next layer. And all this has to be very, secure. So this FDO machinery has to be very secure. That's for sure. So to give you another example of the power of this to create complex data structures and have complex data structures for the future, since what we are doing is creating knowledge for the future. So I cite here our people from the Global Biodiversity Infrastructure community. These are these national, natural history museums and so forth, right? Probably you know them. So in Europe, you have about 120 of these natural history, natural science institutes. And let me just tell you, they have 1,000 collections. They have 3 billion of objects. They're using 2 million standards, right? It's incredible. So everyone does it differently. How in the hell would you like to bring this together? The information together, not the institutions, the information together. And of course, you have trillions of relations. And relations are important. They are, as we call, primary citizens on the web as well, since relations are basically about storing about knowledge. So to give you an example here for this bug, the bug has categorization information, has information where it was found, has gene sequence information, three-dimensional diagrams, and so forth and so forth. Some sounds. So there's a lot of different information about such a bug, and this information is, of course, in different institutions, since they all have their specific capabilities. right? How in the hell do you want to bring this together? And how in the hell want you to store this, maintain this knowledge of bringing this together? You don't want to do it every year or so. No, you need to store this this information so that people can work with it. And what you can see here is an indication of the fair digital object. So they do it with the fair digital object. The first task is then to build this integrated data space and virtually bundle all the information belonging to one specimen. And of course, they use a lot of different tools to get this integration done. And the second task is enable the execution of specific software on the digital twin of an object, which is an FDO. So you can call this a digital twin, finally. And why is the second task so important? Well, think about, and they have this here as well, think about data which you don't want to expose to other people. So medical data. So our brain images, for example, we didn't want to expose them. But what we wanted to do is we wanted to say, okay, you're allowed to use that software, which we know about, on that piece of data. So this digital object is like object-oriented programming in a certain way. It has methods. So you can add, and that's what these people also doing, you can add a method to a digital object, which says, okay, you can use that procedure to access that, whatever kind of task. So I'm done. So FDOs can be used now to build a stable global data infrastructure. So that's the infrastructure part. And it can be used to structure complex data spaces. And as we do it now in a German project, you can combine FDO technology with data protection technology. Then you get a layered infrastructure. I will not talk about this. Yeah. So maybe this is useful for you.